Like we know when you don't have dimensions at all, in the dimension is 0, we are dealing with a scalar, right? Like a number is a scalar, doesn't have any dimensions. When you have the dimension, single dimension, so you have multiple scalars, you would have a vector, right? And when you put vectors together, you would have two-dimensional structure that oftentimes, like it's called matrix in math, right? Higher dimensions, when you put matrices together in a higher dimension, in a higher structure, it's often called tensor. Did you hear about TensorFlow? TensorFlow is a very popular library in machine learning, right? So a lot of the machine learning algorithms are matrices and operations that apply on these matrices, or tensors and operations that apply on these tensors. Tensors are just the general term of tensor was to use for higher order matrices, but actually when you use a TensorFlow library, they use the term tensor to refer to any vector or matrix, any multidimensional structure. Okay? Even the scalar, they call it tensor of 0. So I want to recommend that you pay careful attention to matrices operations because machine learning algorithms built on it very heavily. Okay. Now, how do we work with the multidimensional array as it is defined in NumPy? Now here, the simplest form, we can create a one-dimensional array based on a one-dimensional list. Okay. When you print it, so this is how, first the print statement here, it would look like the list, but it is much more efficient. If you try to compare some operations on a list and an array, the array is much faster. Okay. A very important property in the array is the shape property. So the shape property, as you can see here, is a tuple that has dimension according to the dimension of the array. So when you have a one-dimensional array or a vector, then you would have one element in the tuple. Okay? When you have two-dimensional array, you have two elements. So this would be the number of rows, and this would be the number of columns in each row. When you have three dimensions, you would have the tuple would have three entries or three elements. The rows, and every row, now we can say rows and columns. So when you have three dimensions, it means when we say first dimension is 2, that means that we have two matrices. Each matrix would be 2 by 3. Okay, now let's try them out because that needs a little bit of mental adjustment. Yes. So if you have a matrix, if you have an image, hold on a second. Oh, no, I want it. You have an image. The image is a set of pixels, right? So the pixels, the dimensions of the pixels in the rows in the column, that's two-dimensional array. If you have a color, if you have the intensity of the color, where do you put the intensity? Okay, so you need, so images in general in computing is represented as a two-dimensional, at least two-dimensional. Okay, so when you want to say, I'm just gonna put a dash just to present a very good dot. Okay, so every column here, or every square here is a dot, one pixel. Okay, so let's say you wanna draw A. So you need to shade this pixel and then this pixel. And then let's say and then put one into that. So very basic A. Okay. Now the pixel, every pixel has a row and a column, right? So 0, 1, 2, 3, 4. 0, 1, 2, 3. So you want to say this needs to be shaded. So the pixel at 1 and 2. The intensity of the color. So let's say this would be, if it's gonna be black, let's say it's 1. All right. Now, what if you want to have an extra information associated to this? So let's say you want to have a color, not just black and white. And so where do we put it? There's no place here. There's only one number here, right? So we add a dimension in order to add additional information. So when we say, let's say so the third dimension, you can take a value of range, let's say 0 out of 10. Okay, so you need this here. It would be shaded and it also shaded with a color font. Okay, there's a oversimplification. Usually the color is represented by three numbers, but it's just not given to the numbers. Okay, so the more information you want to associate together, the more dimensions you need. So here in this example, we assume that the color is just one number, but if the color is actually three numbers, then you need to add three dimensions, or to add one dimension that has three components. All right, so let's try this. We're gonna import NumPy as NP. All right. Now I want to define a one-dimensional array. So one dimension NP dot array. Okay. Now I can send it the list of elements that I want the array to be built on. So if I just send a simple list like this, it will create one-dimensional array. Okay, so I can print dot shape, and I can also print the size. So the other property that is very important to use or to know about the array is the size. So what do you think is the size? Now we know the shape is just a shape, how many rows or how many columns. What is the size? What do you think is the size? Any guess? Number of elements, the total number of elements. Okay, so this we should expect. This is one dimension, so there's only one element in the tuple that represents the shape, right? And then the size would be the same as that number because it's just one dimension. It's the simplest form of an array. All right, now see here. We have only one dimension, and that dimension has 3 elements, which means that we only have totally 3 elements. Okay, now what if I want to create a multi-dimensional list? So it's not one dimension more. So let's start by 2. And let's see the list itself and then we will try to transform it into an array. So we create a multi-dimensional list, so two-dimensional list, so list of lists, right? So the outer list is here represented by this square brackets. Inside this list, we have multiple lists. So that's how we create multi-dimensional lists. Okay, so let's say inside we have 3 lists. Okay, now each of them, if it's a list, if the basic list of Python, we can have any number of elements. They don't have to be consistent. So let's say I have here 10, 11, and here I have 6, 7, 8, 0. And 1. Okay, now if I try to print this list, there is no problem. Okay, now if I try to create a multi-dimensional array, a two-dimensional array, so np.array, similar to this exact list, what do you think what happens? Now this, the array in the NumPy should be a proper matrix. Is this a proper matrix? No, a proper matrix must be, all the rows must be consistent. So we should expect that NumPy is going to prevent us from creating that improper matrix, or not properly structured matrix. Okay, so if we're gonna use NumPy, we are like, this is meant for numerical operations, so it has to follow the numerical rules. So it has to be a real matrix. So let's say we're gonna have all of them have 3 elements. Okay, so we have one list that have each element of it is another list. So that will be translated into rows and columns when we turn it into an array. All right, now if I try to print it, doesn't look very different. It would be organized in a way that looks more like the matrix if we print it from here. Okay, so it's pretty much the same, but it is organized in rows and columns like a matrix should look like.